Well, I'll let you take it away. I'll see if I can fill in with a few more folks here.
Well, good afternoon, and thank you, DDN, for welcoming AMD into your booth this afternoon. I'm going to give you a little bit of a presentation and then some insights into our second generation AMD EPYC processors. And as you can see on the slide, I've got a fairly bold claim. We're claiming that it's the new standard for the modern data center. Pretty bold, huh? So I hope that I'm going to give you some information this afternoon that will substantiate that claim. So you may have heard or seen on the show floor some of these customers. This is actually an older list because yesterday we put out a press release with a bunch more customers listed on it. We've got some HLRS. When they release, or they've just released their new Hawk system, it will be the fastest system in Europe. NERSC, when it deploys in 2020, it will be using a future gen of AMD EPYC processors. I've got a couple of cloud providers up there, Microsoft Azure and the Oracle Cloud. For those of you who want to advance your performance of your HPC workload in the cloud. We also announced, you may have heard about the San Diego supercomputing and the new Expanse cluster that they're building. That will be built on AMD's EPYC Gen 2 processors, and they've got a nice bit of information about that in their booth. So let's spend a little bit of time looking at Frontier. How many of you have heard of Frontier? Have you been in our booth yet and heard about Frontier? So when it deploys in 2021, we're going to see 7 times the performance of the current Summit system from the DOE, 7 times the performance at over 1.5 exaflops. And you probably know that Summit was just released again as #1 on the top 500 list. So this one's going to be 7 times higher performance. It will include a future generation of the AMD EPYC processor, along with a future generation of our AMD Radeon Instinct GPUs. And it will include a new custom high bandwidth, low latency coherent Infinity Fabric. Now, you may have heard about our fabric. I'm going to tell you a little bit more about it. This one is going to really rock the world when it comes out, okay? So how do we make some of these claims around the AMD EPYC 7002 series processor? The 7001 was what we called Naples. And then in August, we announced and released the 7002. That's been the one that we've been calling Rome. It is the new standard for the modern data center based on the leadership architecture. And that architecture is built on a very high performance, scalable, efficient, and secure product. And you're going to need that for your current and future HPC workloads. The leadership architecture is going to deliver 2.2 times the generational performance, so an increase over Gen 1 of 2.2 times. And it does outpace our current competitor at their high end, their Platinum 8280 processors, by 84%. We've added some additional security features that I'm going to tell you about in this talk that enable to take control, and rest assured that you do have a secure implementation. Let's spend a couple minutes talking about the Infinity architecture and this fabric. So I mentioned it's super efficient, right? It's built on a hybrid SoC, a multi-die SoC design, and what that means is that we're combining a 7 nanometer design in chiplets, and in those chiplets and 7 nanometers, we're combining the cores with the L3 cache. And those cores are all going to be serviced by a centralized 14 nanometer chip that is going to include the I/O, the PCI Gen, and the memory controllers. So those centralized I/O, when you see the implementation of that, is going to deliver lower latency and actually a more consistent latency than other designs. We're also seeing significant performance upgrades from our former Naples Gen 1 design, 2.2 times the increase. So if you look at 2.2 times the performance and the relative increase in cores from 32 to 64, we're going to see 4 times the theoretical floating operations per second. So you're going to get great performance out of our new Gen 2 processor. The throughput is going to be realized through the PCI Gen 4. We are the first processor to utilize PCIe Gen 4. Okay, so if you're going to need lower latency, greater bandwidth, it will connect to several of the industry leaders who are also connecting through PCI Gen 4. And about security. So we've always had some great security built into our products. But with this new processor design, we've got a secure root of trust. And from what I hear, even with root privileges, you can't hack the system. So you will be not seeing some of the more recent that we've seen in the last year or so, some of the security breaches. So if we look at this a little bit more closely, then, as I've mentioned, we're the first x86 built using the 7 nanometer technology. It's from TSMC. It will deliver a significant performance with faster, smaller, and lower powered transistors. You can look at this in 2 ways, right? So you can either deliver the same performance with half of the power, or double up your density and increase your performance to what you need for your HPC workloads. Okay? So this slide really digs in a little bit more and compares our Gen 1 processor to Gen 2. So in Gen 1, we deployed a 4-die package. And as you can see, we had the CPU, the memory, and the I/O on each of those dies. And they were connected with an Infinity architecture. With Gen 2, what we've done is we've created this chiplet or this hybrid SoC design, right? And each CPU is going to contain up to 8 cores. And each of those cores now has twice the L3 cache memory available. Okay? They then are built on the 7 nanometer. And remember, I told you that there was a 14 nanometer die in the middle with the I/O and the memory controllers. So they all access through the Infinity architecture that same I/O. And that centralized I/O is going to really optimize, give you higher core density, and really optimize your throughput. This architecture is the first of its kind in the industry, and we believe that within the next 5 years or so, more people are going to be using it. Any questions about that? Okay. Oh. So let's look at some of the performance that we're seeing to remove some of the common bottlenecks that I think you probably see in your current HPC workloads. So this PCI Gen Express, we're giving it credit for our throughput increases, right? These processors are ideal for workloads that have extreme storage requirements. So we've got an example there where we're seeing twice the read-write bandwidth for direct connect storage. So think NVMe, think the new EDSFF direct connect storage through SSDs. We're also seeing twice the InfiniBand performance through Mellanox ConnectX. Okay? So we've built these claims, and this is kind of our breakdown of what we've got in the processor. 64 cores. You can use SMT, so use up to 128 threads. You can use 128 PCIe 4.0 lanes if you'd like. With the precision boost power, you can get up to 3.4 gigahertz, depending on your headroom. And it utilizes up to 225 watts. We are seeing 2 times the performance over Intel's 2nd gen 8200 processors. And we've built this not on our own, but we've built this with a lot of world records. In September, we announced 100 world records, and I'm hearing rumor this week that we've increased that to over 140 world records across the board. And these were not accomplished by AMD alone. These are partner records. Okay, these are other people, industry leaders in the industry, creating and releasing these records with us. And this is just a little bit about the broad ecosystem support that we're seeing. So we've got a lot of hardware partners, operating system, and of course a lot of third-party applications. So I hope that you've seen through this short presentation that we have developed the new standard for the modern data center. We've got over 140 world records. We're showing twice the performance and twice the number of platforms over our first gen. So thank you for your time this afternoon.